Hello all, welcome to the first lecture of the class on characterization of particles, powders and compacts. So in this lecture on sampling, we will cover types of sampling, sampling bias, sampling equipment and subsampling or sample size reduction. So this lecture is divided into four parts or four sections, and this first part will cover the introduction of sampling or the need for sampling. In almost all the powder processing operations, sampling is the first step in characterization. So we collect a small amount of sample to analyze the physical and or chemical characteristics of the product. Unfortunately, this is the place where we knowingly or unknowingly introduce bias. So let's look at some of the standard sampling methods, procedures, and ways to reduce sampling errors. So the goal of powder sampling is that the small amount that we collect from the bulk represents the physical and chemical characteristics of the entire bulk. For example, you have to measure the particle size of, say, cornstarch powders that you received in two 250 kilogram tote bags. But the particle size characterization instrument that you are going to use uses about 2 grams of samples for the analysis. So, considering these examples, what will be the best strategy to sample the powders from these bags? Again, keep in mind that the powder may have segregated during filling and transport, handling. So scooping from the top may not be the best approach. So through this lecture on sampling, we will go through some of the best strategies to sample the powders. In general, we may use either online or at-line or even offline sampling methods for powder characterization. In the online method, the sample remains the part of the stream and we use indirect methods to characterize the samples. In an at-line method, this method involves removing samples from the process stream and analyzing them with characterization equipment kept in close proximity to the process stream. In this method, the samples are mostly analyzed immediately after drawn from the process stream. In an offline method, the samples are extracted and analyzed at a remote site. For convenience, offline or online are the most common sampling methods used by the industry. Both these online and offline methods have their own advantages and disadvantages. And most of these advantages and disadvantages are listed in this slide. But the major use of online methods is for real-time process control with less operator bias. But this method requires development of a technique that is reliable and will also require a dedicated equipment that continuously characterizes the powder. While offline method offers the advantage of making detailed measurements, you can use published standards and also well-developed technologies and also specific instruments when you're using offline method. But increased handling or processing will increase sampling error and also input additional bias. But each of these methods have their own advantage and their own disadvantages. A batch of powder can vary, from a few grams to several tons, depending on the process or depending on the industry that you are, working. So when sampling for analysis, bias can be easily introduced during collection and or preparing the sample for characterization. For example, if you're interested in measuring the average particle size of a Chex, granola mix, and if you're drawing samples from the top of the bag, what you will be getting is a large whole Chex squares. But you will be missing, or you'll miss including the bits of nuts, bunch of oats, rice flakes, and even fragments of Chex squares in your characterization sample. But another challenge will be attrition or fracturing of samples when using sampling devices such as thief probe, and these kind of attrition can also lead to sampling bias. So to have reliable and representative samples, extreme care should be taken to minimize bias during collection, preparation, and measurement stages. In general, two types of sampling error can occur within a powder system with a mix of different particles or components. The one is heterogeneity caused by differences in chemical and physical properties of the particles itself. So the error caused by this heterogeneity will be difficult to control even if you have a foolproof sampling method. The second type of error could occur from distribution heterogeneity due to non-random distribution of particles within the powder bed. But this heterogeneity can be overcome by following a good sampling scheme or sampling procedure. The other major challenge will be the sample preparation error. For example, when you're preparing sample for particle size analysis, excessive ultrasonic energy during liquid sample preparation or excessive air pressure during dry powder sample preparation can break down the particles. So you'll not be able to rectify the sample preparation error by having a good sampling plan, but will add to the sample bias or error in characterization. In general, bulk powder with small particles may have smaller extraction errors but may have larger sample preparation errors. But for powder with large particles, the extraction error could be higher with small sample preparation error. But these, effect of particle size will depend on the particle size distribution and the range of particles that you have in the mix. You all know that the purpose of sampling is to gain knowledge of the characteristics of the whole batch of sample that is impracticable, to apply to the whole. So bias at any of this sampling stage will have significant effect on the final analysis. So the total variance will include the actual variance in the sample, variance or error due to sampling, and also variance due to the methods of analysis. Under ideal conditions, the sampling error and the error from measurements should be negligible, but in actual practice, those errors are not negligible and can be very significant. With proper protocols and our focus during sampling is to minimize the total error when you are analyzing a sample. In general, the largest variance occurs during sampling and subsequent handling of the samples. So the handling can induce segregation, attrition, etc., or can change the powder characteristics. But keep in mind that advanced instruments or very expensive instruments cannot amend the sampling errors or powders sampled poorly or using poor sampling practices. So Allen, in his book on particle size measurement, provided two rules to minimize errors due to segregation. The first golden rule of sampling is the powder should be in motion when sampled, and many samples should be taken from the whole of the flowing stream over shorter time periods rather than taking single sample from one location over a longer time period. So following these two rules will ensure that the entire bulk of material is accessible for sampling. And in the next part of the lecture, we'll go through some of the sampling equipment and procedures that will allow us to follow these golden rules of sampling. This ends the first part of lecture on sampling or introduction on sampling. Please feel free to contact me if you have any questions.